So far, we've looked at three gas laws. Boyle's law, where we can look at the relationship between pressure and volume. Gay-Lussac's law, pressure and temperature. And Charles's law, volume and temperature. Consider a problem in which you wish to calculate the final volume of a gas when the pressure and temperature are changed. You can't use any of those three previous gas laws for this. If a scientist considers Charles's law, Boyle's law, and Gay-Lussac's law together, they can write an equation called the combined gas law to represent the relationship among pressure, volume, and temperature of a gas. If we combine these gas laws, we get something that looks like this. PV equals a constant times temperature. The K in all of these equations are not the same. In order to use this new combined gas law equation, one thing has to be kept the same, the number of particles. We can use this version of the combined gas law. Here we have a problem that we need the combined gas law for. A sample of neon gas occupies a volume of 875 milliliters at 31 degrees Celsius and 805 millimeters of mercury. What will the pressure of the neon gas be if the volume of the container is expanded to 925 milliliters and the temperature is increased to 50 degrees Celsius? So we can't use Boyle's law or Charles's law or Gay-Lussac's law because we have both volume and temperature changing. First thing I'm going to do is write down the information that we know. So we have an initial volume, we have an initial temperature, we have to change that to Kelvin, and that is 304.15 Kelvin. And we have a pressure. So whatever units our pressure is in to begin with is what we're going to finish with. We have our volume that has changed and our temperature. And that is 323.15 Kelvin. And we have our final pressure that we're looking for. Now to use our equation, P1V1 over T1 is P2V2 over T2. The first thing I'm going to do is solve for this side of the equation. 805 multiplied by 875 divided by 304.15. Now on this side, P2 be multiplied by just a number. To find that number, you do 925 divided by 323.15. You can see both sides have units milliliters per Kelvin there, so I can just get rid of those. To get our new pressure, we have to divide both sides by 2.86. So our new pressure is 809.75 millimeters of mercury.